All right, so chapter 5 is going to be our start on looking into rational expressions. Um, so rational expressions are really just a kind of like an extension of your polynomials a little bit. So an irrational expression consists of the quotient, or like a fraction, of two polynomials, where the polynomial in the denominator is non-zero, meaning whatever we have down here, it can equal zero at some point, but we're not going to have something like x squared plus 2 divided by 0. Because technically, 0 by itself, this would be a polynomial, but I cannot have a rational fraction whose polynomial on the bottom is going to be 0. So that's all we mean by that. Because one of the things we are going to look at is when it would be, say, these ones right here, and what cases would the denominator be 0 is something we would have to look at. But like I said, these are examples of your rational expressions. So 7 and 8 by themselves, those are polynomials. So 7/8 is a quotient of a polynomial. Having just a variable, that is also a polynomial. Say something like z over -6, or two variables, a over b. But expanding a little bit more, you could have something like a constant divided by something with a y in it, or it could be at the top like here. But just as a reminder, anything that constitutes a polynomial as we had said before, polynomials can simply be something like 7 or x or y squared, but it also could be like y squared plus 2y minus 7. So all we have here is just quotients of polynomials. So a rational expression is the quotient of two polynomials. The set of real numbers for which the algebraic expression is defined is called the domain of the expression. And we all know what a domain is. We've been working with this so far. And we have done domains of rational expressions way towards the beginning of this course. Because rational expressions indicate division, and division by 0 is undefined. We can't divide anything by 0. We must exclude numbers from a rational expressions domain that make the denominator 0. Like I said, this is kind of a review of something we had done already. So recall that when an expression is divided by 0, the result is undefined. So we saw that before. If I had like 7 divided by 0, that was undefined. If I have x squared plus 3x plus 2, and that's all divided by 0, that would also be undefined. So what we're looking for here is, when would something be undefined? A rational expression is undefined for a value that results in a denominator that be equal to 0. So the following expression right here, x to the fourth plus 2 over x squared plus 5x minus 6, that would be undefined as long as the bottom is 0. So I'll give you steps here, but this whole thing is undefined. Sorry, I spelled undefined wrong. When our denominator, so the x squared plus 5x minus 6 equals 0. And of course, we have been playing with polynomials, so if I factor this, we get this, meaning that x squared plus 5x minus 6 would only be 0 as long as x is -6 or 1. Therefore, what happens is the only place that where my expression would be undefined would be at those two numbers. So we want to find all the numbers for which this rational expression is undefined. And like I said, the only thing we're concerned with is when is the denominator 0. Later, we will be concerned a little bit more about what happens with the top. But right now, we're just really concerned when that denominator is 0 because we're trying to figure out the domain of this function. That's going to tell me where it is undefined. Meaning I'm just going to look at x squared minus 3x minus 28. I want to figure out when that equals 0. So I need two numbers that multiply together. They're going to give me 28 and then add to give me 3, which would be 7 and 4, I believe is what I'd have. If I multiply -7 and +4, I am going to end up with a -28. And if I add them, I do end up with a -3. So that would be the factored version of my denominator. Sorry. So if we solve this, we know that this means either x is going to be 7 or x would be -4. So when x is equal to -4 or 7, the denominator is 0, meaning we're going to divide by 0. And when we divide by 0, that's when we're undefined. And therefore, didn't give myself enough room for that, undefined. So this means if I'm looking for my domain, remember we can say the domain is just simply, it can't be -7, or sorry, it can't be -4 or 7, or another way of saying it is that we can have everything from -infinity up to -4. Then we'll have our union, because then I got to start on the other side, -4 up to 7. Then I start on the other side of 7, and I go up to infinity. Okay. But that will give me my domain. So worksheet number 1, take a moment and try to figure out what would be the domain of this particular rational expression, or what we're looking for is where it is undefined. Okay, so like I said before, we're really just concerned where the denominator is equal to 0. So we are going to be concerned with where x squared minus 3x minus 10 is equal to 0. So we'll set that equal to 0, and then we're going to factor. So sometimes you might have to use quadratic formula. Examples I'm given so far are just going to be ones that are factoring, make this a little easier. So we need factors of -10 to add to give me -3, and those would be -5 and +2. So x squared minus 3x minus 10 is the same as saying x minus 5 times x plus 2. So we know that this means, if we solve this, that x is either going to be 5 or x is going to be -2. So we are undefined at x equals -2 or 5, which also translates into my domain would be all x except when x is -2 or 5, or another way of saying that in interval notation is -infinity up to -2, union -2 up to 5, union 5 to infinity.